Hello everyone, hope you are doing well. I'm Reza Mohammad Hassani, the founder of the optimizationcity.com. In this presentation, I'm going to learn how to use the online solver of the minimum cost flow network. A short introduction. In the minimum cost flow network, we are looking for unique product distribution from the factory as origin to sell market as a destination. Suppose the total number of product each unit produced in each factory and the total number of product required at each destination are known and certain. Also, it's not necessary to send the product directly from the origin to destination, but it is possible to send through the distribution center to other places. In addition, the capacity of the constraint of some arc are limited. The goal of this problem is to minimize the cost of the transporting product. In course number 8 of the optimizationcity.com, this topic has been discussed completely. To solve this problem, there are a few software that are difficult to work with them. Optimization City Group has designed an online solver of the minimum cost flow network. In the following, we review how to use this online solver. This is the GUI of the online solver. There are some input parameters. Nodes is the number of the network nodes. Age is the number of network arc. Each age consists of the two directed arc. Num demand are the number of source and destination node. If you have a one origin destination pair, this parameter would be equal to 2. If two source destination pair have a common source node, this parameter would be equal to 3. Node demand here. The demand value of the source and destination node. This matrix has a num demand plus 1 row and 2 column. In each line, the first component shows the node number and the second component shows the demand amount. If the amount of demand is positive, it means that we have a supply, and if the amount of demand is negative, it means we have demand or request for goods. Node I is a vector has no age plus 1 component that store the beginning node of each arc. The first component is considered to be 0. Node J, the vector has age plus 1 component that store the end node of the arc. The first component is considered to be 0. Arc cost is a vector with the age plus 1 component that store the cost of each arc. The first component is considered to be 0. We put a 0 number for the component that do not have an arc. Law bound. The vector has age plus 1 component that store the minimum flow of each arc. The first component is considered to be 0. Upbound is a vector has age plus 1 component which store the maximum passing current of each arc. The first component is equal to 0. So to show how to use this online solver, we use the following network. The 3 numbers are displayed on each arc, respectively the cost of the passing each unit through the arc, the minimum flow passing through the arc, and the maximum flow passing through the arc. The question is to find the minimum cost flow in the network here. This is the input we should enter in the website. One point I should mention that each entry should be separated by comma in the website. So let's go to the website. This is the website, online operation research solver, and minimum cost network flow. Okay. Nodes is 7. Number of arc or age is 11. 2 num demand. Okay, node I have here bottom node j here. As I state, the first component is equal to 0. Our cost, copy and paste here. Low bound, copy and paste here. Up bound, copy and paste here. And node demand, this is the matrix. So we just press the run. Oh, okay, num demand is equal to, I think, 2. Okay, I press the run, and this is the result of the algorithm. In the output, optimal solution found means finding the optimal solution. In the next part of the output, it showed the amount of flow for all arc. For example, from node number 5 to node number 1, the flow is equal to 4. And in the last part, the total cost of the flow is equal to 369 is as an objective function. Thank you so much for watching us. If you have any question, you can send an email by optimizationcity@gmail.com, or you can fill out the contact form in the website www.optimizationcity.com. Thank you so much and goodbye.